right, table G. How do I read table G? There's a whole bunch of lines here and a lot of stuff going on. So let's break it down. What this table does is it allows us to look at the solubility of individual salts in grams per 100 grams of water. So let's just look at one salt. And I highlighted the KNO3 line. Each individual line is labeled with an arrow. So you can see that's the NH4Cl line, or ammonium chloride, that line right there. Hydrochloric acid would be this line right here. So I highlighted for us the KNO3 line. This is showing the solubility of the KNO3 as we increase the temperature. So you'll notice down here on the x-axis, I'll highlight them for you. On the x-axis we have different temperatures, starting at 0 degrees, going all the way up to, starting at 0, all the way up to 100 degrees. And you'll notice that the line has a positive slope. And that means that as the temperature is increasing, the solubility of this salt is increasing. So at 0 degrees, I can have approximately 15 grams of solute dissolved in 100 grams of water. If I increase the temperature to 40 degrees, I could have approximately 65 grams of salt dissolved in 100 grams of water. Notice that this chart always shows us for 100 grams of water. Keep that in mind when we do some practice problems. So I'm going to go ahead and I'm going to grab a worksheet and we're going to try some of these and see what we can do with them. All right, let's try some of these problems using a solubility curve. On this worksheet that I gave you in class, I want you to notice that they have their own solubility curves down here at the bottom. Okay, we're going to use these solubility curves as opposed to the ones that are on our reference tables. They work exactly the same way. There's grams of solute here per 100 grams of water, and then as you go across the bottom, you increase in temperature from, see the temperatures right there, from 0 to 100 degrees. This is the line I had highlighted before, the KNO3. The only reason I'm using theirs is because it might be just a little itty-bitty bit off. All right, let's take a look at this first question. It says, you'll notice for most substances, solubility increases as temperature increases. So that's what we were talking about a few minutes ago. As I increase the temperature, you'll notice that it's a positive slope. Positive slope means that my solubility is increasing as my temperature is increasing. As discussed earlier, solutions involving liquids and solids typically more solute can be dissolved at higher temperatures. Can you find any exceptions on the graph? Well, you'll notice that there is a line here with a negative slope, and that is showing that as the temperature is increasing, the solubility is decreasing. So at 0 degrees, I had a solubility of 90 grams in 100 grams of water. But if I got to 100, which is over here, if I got to 100 degrees, now I can only dissolve maybe 8 grams. So my solubility decreased. This happens when you're talking about gases. So this red line, this ammonia that I have right here, is a gas. Gases decrease in solubility as you increase the temperature. So one of the exceptions on this graph is ammonia, NH3, okay? And the other exception you'll find, I'll do it in green, is right down here. Okay, the slope is a negative slope, and that's the cesium sulfate, Ce2SO4 3. Okay? The next question says, at 30 degrees, approximately 10 grams of KClO3 will dissolve in 100 grams of water. That's just giving us a statement. It's telling us that if we go to 30 degrees, which is right here, see it down on the bottom there, and 10 grams, we are going to end up right on the KClO3 line. If you end up directly on the line, you know you have a saturated solution. So I'm just highlighting that line in green. So there's my saturated solution. At 10 grams and 30 degrees, KClO3 is saturated. If the temperature is increased to 80 degrees, so 80 degrees is up here, I changed my color. If I follow that up, how much KClO3 can dissolve? So we're going to follow it across. and we're going to read 40 grams of the substance can dissolve. All right, this next section says what mass of solute, and remember to keep in mind that mass is always grams, and that is this, grams of solute, can dissolve in 100 milliliters of water. That's good news because our chart gives us 100 milliliters of water at the following temperatures. KNO3 at 70 degrees. So I'll break out a green pen and I'm going to go find 70 degrees on my chart. I'm going to find the KNO3 line. I will highlight it in green. And we're going to follow that 70 degrees all the way up till we get to here. That's where it reaches the line. When I read it across, it will tell me how many grams I can dissolve at 70 degrees. So that happens to be 130. I want you to keep in mind that although when you get these kinds of questions, you might say 129, you might say 131. It's not exact. They always give you a range when you're trying to find these answers. So I'm going to go ahead and I'm going to pause and get the next two answers and you can check your work. Okay, hopefully you got 40 grams of sodium chloride can dissolve at 100 degrees and 70 grams of ammonium chloride can dissolve at 90 degrees Celsius. All right, the next question says which of the above three reactions or three substances must be soluble in water at 15 is the most soluble in water at 15 degrees. Keep in mind that solubility means that it can dissociate when it hits the water. It can break apart when it hits the water. So we want to know which one is going to break apart the most. It's going to give you the most grams at 15 degrees. So we're going to go ahead and we're going to find all three of these at 15 degrees. The KNO3 I just highlighted with a red dot. I put a blue dot on the sodium chloride at 15 degrees, and you can see that right here. I have a blue dot and a red dot. So right now the sodium chloride is more soluble. I can have more grams of sodium chloride than I can have of potassium nitrate at 15 degrees. Let's see what the last one says. And that last one is ammonium chloride, and there's the ammonium chloride line that's coming right between the sodium chloride and the potassium nitrate. So that one has in between solubility. This blue has the most soluble or the most solubility in water at 15 degrees. So the blue is our winner, and that happens to be the sodium chloride. So this answer is sodium chloride.